Good morning, guys. And today I'm just going to do an introduction to electricity in relation to series and parallel circuits. I'm going to just touch a little bit on the different components, and then I'm going to go into what to look for in series, what to look for in parallel, how to answer the questions. This video is aimed at grade 9s and then beginning of grade 10, and then also grade 8s. You can use it as an intro, and then obviously grade 11s and 12s, you can use it as a basis for learning the extra stuff you do in grade 11 and 12. Okay, so I'm just going to start with your basic components. Okay, so remember we have a long line and we have a short line, and that is for a cell. The long line is your positive, the short line is your negative. Your electron flow always flows from negative to positive, and your conventional flows from positive to negative. Okay, when you have a series circuit, you're going to have a long line and short lines next to each other like this. Okay, so that means there's 3 cells in series. If you take your highlighter and you can go through all 3 of them, it means they're in series. Okay. The problem with this is that a lot of people don't know how to draw them properly. You always have to draw the long line next to the short line. There are lots of learners who always want to go long line, short line, or long, short, short, long. You cannot draw it like that. You have to draw a long line next to a short line, whether it's a long line and a short line, or you draw the short line and then the long line, short line, long line. It doesn't matter which way around you go, as long as a long and a short are next to each other. Okay, so that is what your series would look like. Your parallel, they have to be on top of each other like this. Okay, so they would be on top of each other. And then you need to have your connecting wires connecting them to each other. Okay, this would then be a parallel cell. You again have to remember a long line and a short line, and then the one below it must then be long and short. If you do a short and long up here, you must do a short and long down there, because all the positive sides must be on the same side and all the negative sides must be on the same side. Some teachers do like to draw it when it looks like this, where they will just have this being the circuit over here, and then the rest of the circuit follows over here. Okay, so some teachers like to have it down like that. I don't. I like to draw mine like this because I find that that looks like a little bit more parallel, but that's me. Okay, so that would be your cells. So that's your cells. We should all know the other components because they're components that we've been using since grade 8. But those components would then be your let's make it red, would be your light bulbs. Okay, so it's a circle with a cross. This is what your light bulbs would look like. In the past, light bulbs used to look like this, okay, with a line through them like that. They don't look like that anymore, but if you do see them in past papers, that's what that is. It's a light bulb. Okay, but this is now how we draw a light bulb. A light bulb is a resistor. Please remember that anything that uses electricity is a resistor. So you need to treat the light bulbs as you would treat a resistor. They have resistance, they have voltage potential difference, and they have current strength. Okay. The next component that we all need to focus on are these rectangles. Okay, these rectangles are your resistors. They could be light bulbs, they could be motors, they could be fans, they could be anything. A resistor is anything that uses electricity. So this would be your resistor like this. We used to draw resistors like this. Okay, we now don't draw them like that anymore. We draw them like this. But if you do see them like this, just note that it is a resistor. Okay, series obviously would be one resistor after each other like this. Please note that my diagrams are not, the lines are not actually touching. Yours need to touch. Okay, and then obviously for a parallel, they're going to be one on top of each other. So again, you're going to have another one over here like this, and then that would be your parallel resistors. If your resistors are on the side in parallel, they would look like this. Okay, it just depends on which side of the circuit that the resistor is on. Okay, so that would be your series and your parallel resistors. You've got your light bulbs, you've got your cells. The last sort of components that we really need to make sure we are understanding, especially in in grade 9 and 10, which this video is aimed at, okay, is your voltmeters and your ammeters. Okay, so your ammeter is nice and easy. It's got a capital A inside like that. It's an ammeter. It measures the current strength. It doesn't use electricity, so it doesn't have a resistance. It just measures how much current is passing from here to here. That's what it's doing. It's just measuring the current. Okay, they are connected in series. If they are connected in a parallel section of the circuit, they are only measuring that series portion. They're not measuring the whole parallel portion. They're just measuring that series portion because they have to be connected in series. The other one is a voltmeter. So again, it's the circle with the V, voltmeter, capital V, okay? They are connected in parallel over whatever they are measuring. So here we have a resistor in the rest of the circuit. This voltmeter is going to be over whatever it is measuring. They are in parallel. So as the electricity enters, okay, it's going to get measured. And as the electricity exits, it's going to get measured. And whatever enters and whatever exits will then tell you what voltage this specific component is using. So let's just for interest's sake say that 10 volts is entering and 8 volts is exiting. We know that this resistor is using 2 volts. Okay, so that is what the purpose of a voltmeter is, and that is why it has to be connected in parallel. Okay, so each of these voltmeters would measure the voltage of the specific cell. If we had if we had the resistors or cells in parallel, so let's say I have this connection over here like this, okay? If I had a voltmeter over here, this voltmeter is only measuring this resistor. If I had a voltmeter over here, this voltmeter is only measuring this resistor. But if I had a voltmeter over here, that means this voltmeter is measuring both of them together because it's joined at a different place. It's not joined over the component. It's measuring the whole of the parallel section. Okay, so just be able to understand how we look at parallel and series and be able to recognize what the voltmeter is actually measuring. Okay, while I'm doing this, I'm just quickly going to show you if the ammeter was connected over here, it is measuring the circuit as normal in parallel. But let's say the ammeter was now over here. This is your A1, and over here, let's say, is A2. Okay, we all know that current gets divided in a parallel section. So when current enters the parallel section, some of it is going to go up here and some of it is going to go down here. Okay, not even. The only time it gets split evenly is if both resistors have the same resistance, but it's not always even. So if 3 amps is entering, that means some of it goes through here and some of it is going to go through this resistor. And that is why we say that ammeters need to be connected in series because they're only measuring the series portion of that circuit. This ammeter A2 is not measuring anything to do with this part. It's only measuring to do with this part. So just be aware of how ammeters are connected and what they are also measuring. Okay, so let's get into the nitty-gritty of everything. So let's go to the next slide. All right, that's the next slide. Okay, so this is just a basic circuit. I've got an ammeter A1, I've got an ammeter A2, and I've got a resistor R1, R2, and R3. So it's always, whenever you get a question, it's always nice to start and use your highlighters and take your highlighter and go through the circuit to see what is series and what is parallel. So here are 3 cells in series because as I take my highlighter and I go through all 3 of them, they are in series. I then take my highlighter, I go down, I go through this ammeter, it's in series, I go through this resistor, and that resistor, all in series. I didn't have to split my highlighter into 2. I go through this ammeter, also in series, and I go back to my cells. So that tells me that this is a series circuit. The whole circuit is series, okay? So now let's look. If each cell has 3 volts, so here's cells, there's one cell over here, there's one cell over here, and there's one cell over there. There's 3 cells. How many volts are in total coming from the battery? So this is your battery, there's 3 cells. Each cell has 3 volts. When you have a series circuit, you need to add all 3 together, because in a series circuit, we add the voltage to get the total. So V total, I always like to use little subscripts to say what I'm trying to figure out, is going to be 3 plus 3 plus 3, which gives me 9 volts. Okay, in a question in grade 8 and 9, that would probably give you 1, maybe 2 marks. It depends. Okay, so that would then be 9 volts. Nice and easy. It's a basic question that they could ask. In grade 10, you could get a question like this, but it would just then be for 1 mark, and it would just be testing whether you know how to add series and parallel. Okay, then we're moving on to resistance. Here, again, in grade 8, we learn how to do this. In grade 9, it's a basic concept that you already have to know, and same for grade 10. Calculate the total or the effective. They're using the correct terminology here. They're not trying to trick you. They're using scientific terminology. Effective resistance, okay? It's the total resistance. They're going to use the word effective, not total, because they're trying to teach you to think scientifically. Okay, but this is a series circuit, so it's nice and easy. In a series circuit with the resistors in series, all we have to do is add them together. Okay, so again, RT for our total. I'm just going to give you the equations, R1 plus R2 plus R3. Okay, this is my equation. Maybe it's for a mark. Doesn't really matter. Grade 8, it'd probably be for a mark. In grade 9 and 10, you just mark for the answer. Okay, so we have a 3, a 2, and a 4. Yes, I know I put them in the wrong order, but doesn't matter. So we have 5, 6, 7, 8, 9 ohms. Okay, and there's that little horseshoe shape thing. That's your ohms. Okay, I don't sit there and draw an omega sign like that. Okay, it takes too much time. So I just draw my ohm like that. I also like to underline with an arrow my final answer. So that would then be my answer. Okay, so in a series circuit, the resistors, we just add them together. Okay, this is a series circuit. There is no parallel portion, so we can call it a series circuit. Okay, then we move on to the ammeter readings. We have an ammeter over here and we have an ammeter over here. The question tells us that this ammeter is 2 amps. The phrase I like to tell my learners is no matter where you put the ammeter in a series section, the reading is going to stay the same. The only time it's not the same is when it's not in a series circuit, okay, when it's in the parallel portion. But no matter where you put the ammeter, the reading is going to stay the same. So if this one is 2 amps, that means this one is 2 amps. So that means A2 is going to also equal 2 amps. Because A1 equals A2 because they're in a series circuit. If I added another ammeter over here, it would also be 2 amps. If I added another ammeter over here, it would also be 2 amps because it's in a series circuit. No matter where you put the ammeter, the reading will stay the same as long as it is in a series circuit. Okay. Then the last rule for series is your voltmeters. Again, nice and easy because it's in series. Everything is easy when it's in series, and that's why only grade 8s learn about series. Okay, but in grade 9, we throw in a little bit of parallel calculations there. So here I have same circuit, but now I have a voltmeter over these 3 cells. I have V1, V2, and V3 over each of the resistors. Okay, so remember this resistor is measuring from here to here. This resistor is measuring from here to here, and this voltmeter is measuring from here to here. Okay, so these voltmeters are measuring those resistors in series. Okay, so the question tells us that this voltmeter is 9 volts. We calculated that before. If V1 is 2 volts and V2 is 4 volts, how much is V3? The awesome thing about voltage in series is that we just add them together, just like for resistors. So V total is going to be V1 plus V2 plus V3. They told us V total was 9. They told us V1 is 2. They told us V2 is 4. We can then solve for V3. Okay, so these are pluses on this side, so it's a +6. When we take it to this side, it becomes a -6, and that means we then have 3 volts. Please use your calculators. There's a very common mistake in physical science is that a lot of kids in a stress environment like an exam, you try and use your brains to do this, and then something goes wrong in your brain and you put 6, and then it's wrong, and then the rest of the questions then become wrong. Rather, just use your calculator just to be sure so that you know that this is going to be right. Okay, don't be a superhero, use your calculator. This is not maths where you're not allowed to use one. Please use it. Okay, so that is for series. That is your how to calculate your ammeter readings with your current, how to work out your potential difference with your voltage, and how to work out your voltage in a series circuit where we just add them together. Okay, the next one is parallel. So this is a basic parallel circuit. Over here, I have 3 cells in parallel, and over here, I have 3 resistors in parallel. We know this because we've taken our highlighter, we come into the cells, it needs to get split, so that means there are 3 cells there in parallel. We then go with our highlighter, ammeter is in series. I then get to this point and my highlighter has to split into 3, which means these 3 are in parallel. Okay, I then get back here, I go through the ammeter, which is in series, and I go back again. So it's really important that you do use your highlighter to understand what part is in series and what part is in parallel. In grade 9, you're only going to get series and parallel circuits separate. But in grade 10, you're going to get series and parallel circuits together. So you're going to get a combined circuit of a portion of series and a portion of parallel. So it's really important to note what part is in series and what part's in parallel. Okay. So let's just get straight into the parallel portion. Little bit more difficult for these. Okay. So here we have it says if each cell provides 3 volts. So that means this is 3, this is 3, and this is 3. In series, we just added them together. We said 3 plus 3 plus 3 is 9, 9 volts, great for series. But parallel is not the same. A parallel circuit is a current divider. So we need to do a little bit more maths to be able to figure out what is happening. And this is the beauty of parallel, is that they are in parallel. So you would think it's 9 volts. So you have a lot of batteries, a lot of cells, but you're not actually getting 9 volts out. So you take the 3 plus the 3 and the 3, because there's 3 there, okay? They're all 3 volts. And we divide by how many cells there are, and we get 3, okay? 3 volts. So this, when they're in parallel, even though they're all 3, only 3 is exiting out. Okay, so parallel might use lots of cells, but the voltage that is coming out is a lot lower. Okay, so this means that the batteries last longer. Okay, but it just means the current strength is not that great. So if you need something with a very high current strength, you're going to use series. But if you want your batteries to last longer, you're going to use parallel. Okay, so it's a little bit trickier than series, but you just need to know that parallel are current dividers, so we need to divide by how many there are. Okay, then we move on to ammeters. Again, it's basic, but you do need to make sure you understand. So remember we said this one is in series and this one is in series. So both of these are going to be the same. They tell me that it's 2 amps. So this is 2 amps and this is 2 amps. Great for them, they're in series. But once I get here, my current gets divided. Some current goes down there, some goes down there, and some goes down here. There are 3 sections to my parallel circuit. So that means my current needs to get divided by the 3 parallel sections. But it's not equal. Remember, it's only equal division if this resistor, and this resistor have the same resistance. So if they were all 1 ohm, then it would be divided equally. But they're not all 1 ohm, so we can't divide it equally, okay? This one says A3 is reading 0,3. Then it says A4 is reading 1,2. So 2 amps is entering and 2 amps needs to leave. So it's really easy for us to work out. So ammeter 2 is going to equal A3 plus A4 plus A5. Okay, A2 was 2 amps, A3 was 0,3, and A4 was 1,2. We can solve for A5. So this is 1,5. When I bring it to this way, it becomes negative. So A5 is equal to 0,5 amps. Because in a series circuit, you add these three together to get the total current. So you add this one, you add this one, and you add this one to get the total current in the series portion of the circuit. Okay, so just understand that the current gets divided, not always equally, okay? And each resistor is then going to use a different current based on the resistance that it has. Okay, so please make sure that you understand that process because it's really, really important in grade 9 and then taking it to grade 10. So grade 10 is when we start using it a lot, obviously in 11 and 12 as well. Okay, then here I have my voltmeters. The beauty about voltmeters in parallel, as long as the whole circuit is parallel, as long as there's no series part. So let's say I had a resistor here. This rule wouldn't work if I had a resistor in series. Okay, so just be aware of that. This rule wouldn't work if I had an extra part in series. But the beauty about voltmeters in parallel is that they all equal each other and they all equal what is over the cells. So we already worked out that this one, the total voltage here was 3 volts, not 9 like it was in the series. This is 3 volts. So the rule is that no matter how many voltmeters there are, they're all going to be the same. So V1 will also equal 3, V2 will be 3, V3 will be 3, and Vp, which is V parallel for the whole section, will be 3. And Vt is also 3 over the cells. So the rule is for parallel, as long as there's only parallel in the circuit, all the voltmeters equal each other. Okay, and this is not a trick question in grade 10, but it's a question that they do tend to ask because they're testing, do you know all the voltmeters are the same in a parallel circuit? Okay, then this is the last part of this video here, just the resistors in parallel. A lot of people find it difficult, but it's not the science they find difficult, it's the maths. Okay, so we have 3 resistors here. They are in parallel. Okay, we cannot just add them together because remember, parallel are current dividers. So we need to divide the current. Okay, so the equation is 1 over Rp for parallel is equal to 1 over R1 plus 1 over R2, 3, 4, 5, 6, depending on how many resistors you have. Here I have 3 resistors, so I'm going to go up to R3. If I had 4, I would go up to R4. Okay, this equation is given on the data sheet in grade 10, 11, and 12. In grade 9, we would probably also give it to you on some form of data sheet as well. Okay, so this is the equation. Parallel circuits are current dividers, so we need to have a division of some sort. And then this is where this comes in. Okay, so we know that R1 is 2, we know that R2 is 3, and we know that R3 is 4. It's basically like maths, okay? But we need to be a little bit showy. So you need to show me your calculations because you get a mark there and you get a mark there, okay, in grade 9. Now, what is the common denominator between 2s, 3s, and 4s? It's not 4 because 3 doesn't go into 4. Not 5, not 6 because 4 doesn't go into 6. So we're looking at 12. How many times does 2 go into 12? 6 times, okay? How many times does 3 go into 12? 4 times. And how many times does 4 go into 12? 3 times, okay? Then we add them all together. That gives me 13 over 12. So 13 over 12. But what you need to remember is that this was 1 over R parallel. I don't want 1 over R parallel. I want R parallel by itself. So what you do to this side, you must also do to this side to get it by itself. So R parallel is going to be 12 over 13, you get a mark for that to show me that you tipped it over. 12 divided by 13 is 0,923. The 3 doesn't make the 2 a 3, so we just say 92 and ohms. Remember, we always round off to 2 decimal places. Okay, and this is how you would deal with series circuits in parallel circuits. You have to make sure you are using this exact equation so that you get the marks. Please don't just do the maths and write the answer down from your head. You have to show me calculation because that is the physics portion of this. Okay. I hope that made sense. Watch this as much times as you need to be able to get those concepts of the basics. These basics are grade 9 basics. So if you're in grade 8 and 9, grade 8, you can just concentrate on the series and a little bit of the parallel, except for this slide that's on now. Grade 9, all of what I've just done is for you. Grade 10, all of what I've done is for you, but in grade 10, we make it slightly more challenging. Grade 11 and 12, again, you know that yours become more challenging now. Okay, my next video will be me doing examples of the different scenarios. Okay, till next time, bye.